Hi, my name's Chris Noble. I'm an independent IT consultant. My website is www.doglikeHorse.com. I'm here to talk to you about basic computer network troubleshooting. The things you'll need for this are a basic understanding of TCP/IP, the networking protocol, a computer, a network, and spare Ethernet cables. The first step when troubleshooting any network problems is to get back to basics. You'll need to check that you have power to your router or hub. So you'll need to make sure that the lights are flashing and that the green lights in particular are flashing. Read the instructions from your router or hub's manufacturer, which will tell you what different flashing lights mean. Typically red or amber lights mean there's a problem somewhere along that line. The next thing you'll need to do is to check the actual connections between computers. Often the simplest networking problems can be, or the hardest networking problems can be fixed by checking the cables and checking that the connections work. If you're finding that the problem to a network is just with one particular computer, try replacing the Ethernet cable to the router from that computer. Once you're confident that the computers are all connected to the network and the Ethernet cables are working and that you should be able to communicate between computers, the best way to check whether there's communication happening is to use a protocol called ping. It's a tool called ping. You can use that on a Mac or on a PC. On a PC, you just open up a command prompt, type CMD in the run box, and type PING space, and then the IP address of the computer you wish to ping. On a Mac, you just need to open a terminal window and type ping space and the IP address of the computer you're trying to connect to. If you can connect, there'll be a reply, and it'll typically be about 64 bytes of data you'll get back. If you can't connect, that window will tell you so, in which case you need to go back and figure out what's wrong with the hardware setup. My name's Chris Noble. Thanks for watching this video on basic troubleshooting for a network.
This is a basic troubleshooting methodology. There are 6 steps involved in troubleshoot network. Discover problems. Identify and document problem symptoms and search technical information resource to determine whether the problem is a known condition. Evaluate system configurations. By review system history to determine what configuration change occur since the computer last worked correctly. Track possible solutions instead of using the trial and error approach. Execute a plan. Test potential solutions and have a contingency plan. If the solution do not work or have a negative impact on the computer, be sure to back up critical systems or application files. Check result. Determine whether the plan was successful. Have another plan in place to address unresolved issues. Is it work? If no, back to track possible solutions, execute a plan, and check result again. If yes, take a proactive approach after resolving the problem by organize the notes and evaluate the experience. Think about the way to avoid or reduce the impact of the problem in the future. Document all changes that make along the way while troubleshooting the problems.
Welcome to Network Troubleshooting. As many of us know, networks do not always function as we would like. Therefore, one critical skill that all networkers should continuously work to develop is troubleshooting. A networker with good troubleshooting skills is always a tremendous asset to his or her employer. This presentation provides a framework for troubleshooting networks. Although each network outage has its own specific symptoms and causes, it is important to know and practice the methods presented in this video because they provide a systematic approach that will enable you to more quickly solve your network's problems. By now you should be very familiar with the characteristics and functions of the layers of both the OSI and TCP/IP models of networking. You also know that the many different types of network devices operate at specific OSI layers. Using your knowledge of the network layers, each of their functions, and the different layers at which network devices operate is a very powerful tool in the world of network troubleshooting. Using a layered model as a framework for networking enables us to use three different troubleshooting strategies. These are top-down, bottom-up, and divide and conquer. Based on the symptoms of your network problem, you may find it valuable to use one of these methods over the others. Let's take a look at each strategy. When using top-down troubleshooting, the networker begins troubleshooting at the application layer and works downward toward a solution. If you suspect that a problem is user-oriented or due to application software settings, the top-down troubleshooting approach should be used. Unfortunately, if the problem turns out to be in lower layers, time and effort is wasted when using this approach. As you might suspect, when using the bottom-up approach, the networker begins at the physical layer and works upward toward a solution. Using this approach can take a long time if the problem ends up being at the upper layers rather than the physical layer. Experienced troubleshooters prefer to use their past experience as guides and apply the divide and conquer strategy. This strategy is characterized by troubleshooting a specific layer of the OSI model and working up or down the model toward a solution. As you accumulate knowledge and gain experience as a troubleshooter, you will be able to use your knowledge and instincts to quickly diagnose problems and formulate solutions to a variety of network issues. Now that you know the different approaches that are valuable for troubleshooting, let's start building your knowledge base by introducing you to some common problems that occur at specific OSI layers. As you troubleshoot your network problems, think about the following common issues as potential causes. Lack of connectivity or slower than average connectivity can be caused by many physical layer issues. When troubleshooting at the physical layer, always consider seeking out faulty or incorrectly terminated cables, electrical interference, duplex settings, or even faulty ports as possible points of failure. Remember, the physical layer is responsible for the physical and electrical specifications for the transmission of bits from one host to another over the physical medium, either wired or wireless. So always be thinking about what may negatively impact these specifications when troubleshooting at the physical layer. Common Layer 2 issues include faulty NIC drivers or a faulty NIC, mismatched WAN encapsulation protocols, and excessive broadcasts due to large broadcast domains. The most common indicator of a Layer 2 problem is the line protocol down console message given after issuing the show interfaces command. Errors in IP addressing are some of the most common errors that occur at Layer 3. Errors in subnetting, route aggregation, and routing protocol implementation and interface addressing can quickly lead to entire network outages. Therefore, always review new addressing information before implementation. If addresses are being distributed by a DHCP server, make sure the DHCP server is correctly configured. Network address translation can also add a level of complexity to troubleshooting Layer 3 problems. Access lists and address pool information associated with NAT should be checked for accuracy. Layer 4 specifies the port numbers used to reach applications. Those port numbers in turn can be used by firewalls to filter application-specific traffic. Therefore, always consider a firewall configuration error if specific traffic types are not reaching the network or endpoints on the network. A common indication of Layer 4 problems is users reporting that some web services, especially video or audio, are not reachable. One way to isolate application layer errors from other lower layer problems is to first confirm that the network layer is functional. For example, if a workstation cannot access a web server, try pinging the IP address of the web server from the affected workstation. If the ping is successful, then layers 3 and below are functional. Firewalls can then be checked for proper Layer 4 rules. If web services still cannot be established, an upper layer issue probably exists. DNS settings, client and server application settings, or simply a mistyped URL can be the problem. Network troubleshooting is a skill that is continuously developed over many years. As a beginner, you should always start simple and use a systematic approach while using the OSI model as a framework. As you build your own knowledge base of network problems, their symptoms, and their solutions, troubleshooting, although challenging, will become a very rewarding part of your role as a network engineer.
Hello and welcome to Saki Tech. So this video is about a series of network troubleshooting tools that you can use in command prompt to troubleshoot your network and get some information on your network. So in this video we're going to go over 4 commands: the ipconfig command, the nslookup command, the ping command, and the traceRT, the traceroute command. So let's start with ipconfig for now. Okay, so the first command that I want to go over is the ipconfig command. The ipconfig command is a very common and very useful tool. It displays the current information about your network. So it will give you basic information such as your IP address for the computer that you're stationed on. It will give you the IP address of your router. It will tell you where your DNS servers is, where your DHCP servers are. So let's type in the basic ipconfig command to start. And usually your local area connection is called the Ethernet adapter local area connection. So this is the connection where you plug in your network cable. The RJ45 network cable connects to the jack behind your computer, and this is the information pertaining to that connection. Anyway, you can get your IP address on this screen, which is 192.168.1.10. It's also called the IPv4 address. You can get your subnet mask right here, and you can get your default gateway address here. The default gateway is your router. So now I know the IP address for my router by looking at this screen. As you can see, you don't get much information about your local area connection here. So what I'll do is I'll clear the screen, type in CLS to clear the screen, and type in ipconfig/all to get more in-depth information about your local area connection. Press enter, and let's go back up to the Ethernet adapter local area connection. This time, as you can see, there's much more information present. The IP address is still here, the subnet mask is still here, the router address is still here, but this time you can also see where is your DHCP server. In my case, as you can tell, the IP address is the same as the router address. That means that my DHCP server is currently residing on the router. And then your DNS server, my DNS server, is also 192.168.1.1. It's the same as my router address. That means my DNS server is also on my router. So you can see how this tool is helpful in troubleshooting and information gathering. Information gathering is a part of troubleshooting. So, when it comes to networks, DNS, DHCP, the default gateway, the subnet mask, these are all important keywords, and you can get the information about these guys right here. So if you were trying to troubleshoot the DNS server, you can beforehand type in the ipconfig command and find where the DNS server is. So in my case, it's in the router. So I would go to the router settings to tweak the DNS server. Okay, so let's move on to the next command. This is all I want you to know about the ipconfig command. So clear the screen and let's get on. Okay, so one of the commands you'll be using a lot for network troubleshooting is the ping command. Ping command allows you to send a signal to another device, and if that device is active, it will send a response back to the sender. Now, for those of you who are interested in the details of how this works, the ping command is a subset of the ICMP, Internet Control Message Protocol, and it uses what is called an echo request. So when you ping a device, you send out an echo request, and if the device you pinged is active or online, you get an echo response. So already you can tell why this is a good command to troubleshoot. So for example, if your router is down and you try to ping it and you get no response, then you know that the router is what is giving you problems. So let's run this command a couple times and see what kind of results we get. So let us ping my router. Ping 192.168.1.1. Press enter, and we will analyze the printout here that we got. So what happens is we send out 4 packets to the destination, and the destination responds back with the same 4 packets. So as you can see here, 1, 2, 3, 4. So this is a reply from 192.168.1 and 1. That is my router. We sent out 32 bytes of data and we got back 32 bytes of data, and we got it back in less than 1 milliseconds. Down here you get a summary. So it says packets sent 4, packets received 4, packets lost 0. So that means this is a stable connection. And then there's some statistics here that is not important. So this is how the ping command works. It sends out an echo request using data packets of minuscule size, and then you get a response and you know that the other device is actually alive. So let us ping Google, www.google.com, and see what happens. So we got a similar printout. Let me just bring this to the top, and as you can see, this is the IP address of Google, and that is where we got the response from. As usual, we sent out 32 bytes of data, but as you can see, because Google is far away and not in my basement, it took 29 milliseconds to send to get a response from Google. And if you look down here again, statistics are packets were sent 4, received 4, lost 0. So the connection was stable. Finally, let's ping a device that doesn't exist. This is going to yield the same kind of results if a device wasn't actually working. So if your router was down and you pinged your router, but you were not going to get a response from it. So let's see, ping 192.168.2.200. Press enter. So we're pinging it right now, and the request was timed out because that device does not exist. As you can see, the ping command is retrying. It's going to retry 4 times. The first packet didn't go through, second packet didn't go through, the third packet and the 4th packet did not go through. And as you can see at the summary, packets sent 4, received 0, and lost 4. So it was 100% lost. The signal does not exist. So if you ping a device, you get no response, and you lose all the packets, that means the system you're trying to reach is not connected to the network. It's having network problems. And this brings us to the end of the ping command. Let's clear the screen and move on to the next command. So the next command is the trace RT command. So what the trace RT command does is it lets you see step by step a route a packet takes to the destination that you specify. So if you send a packet to google.com, before the packet actually reaches google.com, it goes through a couple of routers to reach the destination. So it'll go to your router, then it will go to Verizon or Comcast router, and from there it's going to go to all kinds of different routers before it reaches Google servers. So you can also use the term hops instead of routers. So if it takes 10 routers to get to google.com, you can instead say it took 10 hops. So how do you use this command for troubleshooting? Let's actually run the command and see what kind of results we get. So I'm going to run the trace RT command, and I'm gonna trace google.com. Okay. So as you can see, we're getting a list of each of the routers that we're hitting as we are closing in on google.com. And up here it will tell you what you're tracing, and it'll give you the IP address for Google. Okay, so the trace is complete. Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We went through 11 hops, 11 routers before we actually reached google.com. Now if you look up top here, the first router that we actually hit was my own router. I can tell by the IP address right here, 192.168.1.1, and it's the wireless broadband router.home. The next one, because I have my service through Verizon, was Verizon's router. So it clearly goes step by step through all the hops. And then after 11 hops, we were at google.com. What is the significance of this? Let's say your home network was perfectly fine, but there was a problem with the Verizon routers. You can run the trace RT command, and if there's any problems here, it will actually tell you what the problem is. It could say things like request timed out, destination unreachable, or it could also say that instead of 16 milliseconds, it could be saying like 5,000 milliseconds, just to give an example. And I don't think you'll ever see that. But so if the request times out, that means the problem lies with one of the routers that has to do with Verizon. And then you can call Verizon and you can tell them, hey, you guys are having a problem because I know that my router works because I ran the trace RT command. So this is the idea behind the trace RT command as far as troubleshooting goes. Okay, so that brings us to the end of this command. Let's clear the screen and move on to the final command. Okay, so the final command I want to talk about is the NS lookup command. This command will fetch the DNS records for a given domain name or an IP address. Remember, the IP addresses and domain names are stored in DNS servers. So the NS lookup command lets you query the DNS records to gather information. So let's say I wanted to know the IP address of google.com. I could simply type in NS lookup and type in google.com, press enter, and let's analyze this printout. So the first two lines here show you which DNS server was used to get these results. My DNS server happens to reside on my router. As you can see, 192.168.1.1 is my router. So that is also my DNS server. And the answer that we got was this. All these IP addresses here are Google's IP addresses. Now Google is a huge website. Obviously it's not going to have one single IP address, and obviously the IP addresses will change from time to time. But if you type in any of these IP addresses in your browser, it will take you to google.com. So this is the basic idea behind the NS lookup command. Okay, so this brings us to the end of this video. And if you guys liked the video, just click the like button. And if you like my videos, subscribe to my channel, because I will be updating more and more videos of this sort. And thank you for watching. Have a good day, guys.
This is Hoirudin, Lokman, and Toipo. They are students of electrical engineering. They want to make automatic troubleshooting net connectivity problem. The tools are wall jack, USB cables, router, and computer set of wireless network. On making an automatic troubleshoot for internet connectivity problem, we go to the control panel, First we open the library, go through control panel, double click on network internet, network engineering center. Here there's a line on troubleshoot problems, double click on that. We will choose internet connection to find and fix problem with connecting to the internet or to website. Double click on that. It will appear a window on troubleshoot and help prevent computer problems. It will find and fix problem for you. Next, troubleshoot my connection to the internet. Please. It will solve the problem. Okay, the problem found and it is detected and automatically troubleshoot. So the troubleshooting has complete. Close the troubleshooter. Close the window and try open a browser. Open a Google. Aha! It is done. Your connectivity has been fixed. Thank you. Hey, next we want to make manual troubleshoot for internet connectivity between computer and computer, or else we say it as peer-to-peer. Go to the control panel. To the library, we go to the control panel. Okay, we go to the network and internet. We go to the network engineering center. And at the bottom, we go to the window firewall. Turn on or turn off the window firewall. So we need to turn off the window firewall so they can share my media queue. Okay. We go back to the last step that we left. Go to the internet. Go to the properties. We go to the internet protocol version 4. Click properties. Before it obtain an IP address automatically, then we should use the following IP address. Enter the IP address. Click OK. Close and close. Okay, next we go to the command prompt. Okay, first we type ipconfig to verify the network connection. Here we can see all the connection between this computer to the other network. Next, we have to ping 192. Okay, we see the both computer it get reply, that means there is no internet connection loss. Next, we change IP address between two computers. You see, the connection are success between these two computers. Okay, we can just pop the command prompt, go to the library and go to the network and see if there any connection between this computer to other computer. Wait a little moment until it load all the connection. Okay, the proof that this computer has been connected to the second computer, we can go to that computer. Wait a moment, it is still loading. Didn't find there's appear a window of security, we can just insert password and the user. And then if you open the computer name, we can access any document in that computer. You see, the proof is, example, I go to my document and I copy one file from my computer to the second computer data. Okay, paste right here. Second computer and see on this folder, you can see the document for what I placed before. Okay. That means the internet connection a success. Okay, thank you.